Example 3. Let's do the exact same thing again. This time, your gross income is $5,000 per month. That's your income before taxes. The rate is now J2 equals 8%. Let's write that in as we go. And we're looking for a 3-year term and a 20-year amortization. 20 years, and everything is monthly. That means we have 240 months on our mortgage. We can afford as our maximum payment, well, 30% of that $5,000. So let's multiply that by 30%. And now we know we can afford $1,500. And you can do this on a calculator. So I'm going to go ahead and write in that my payment is $1,500. We're always going to pay it off in complete, always an ordinary annuity. And here, because it doesn't say, we're doing monthly payments. Let's compute. Our PY and CY stay the same through this whole lesson. So I don't have to worry about that. But I do have to reset N, IY, present value. Let's skip. Payment is $1,500 and the future value is 0. So when I compute my present value, it turns out I can afford, or you can afford, $181,000. And $181,081.24. That's the size of our mortgage. After 3 years, you renew your mortgage at the same rate, but are able to make a $10,000 payment, like we did last time. We're going to run through 2 scenarios. First, we're just going to assume that we're going to amortize over the remaining 17 years. This means our payments will decrease, freeing up cash flow for other things. Our other option, which we'll do next, is keep our payments the same and then our time will decrease. Both of which are all right. So let's see how much money we owe after 3 years. We owe, well, that's going to be P2 equals 36. So P1 is 1, P2 is 36 or 3 years. Well, we owe $168,000. And 40 cents. So at the end of 3 years, we owe $168,000. We're going to make a $10,000 payment. So I'm going to take that number. I just pressed clear one time to make it just the number itself. I'm going to subtract 10,000, and that is going to be my new present value. So let's write that in, $158,441 and 40 cents. I'm going to recompute my payment. Everything else stays the same except for my N, because I have 17 times 12 is 204 payments left. So let's change that N to 204 and recompute the payment. And I get $1,410.95. Because I'm rounding that up. Now let's say we wanted to keep our payments the same. We know we can afford $1,500 even though we owe $158,441. We have a lower balance and we could get away with a lower payment, but we don't want to. Everything's going to stay the same except for the N, which I'm now going to recompute. Monthly payments, semi-annual compounding, etc., etc. So let's make our payment back to $1,500, which is higher than the $1,410 that we needed. Now, when I compute N, I get N is smaller. 180, it's a little over 15 years. It's 15 years and a tiny little bit. So we've now saved 2 years off of our mortgage. We've also saved interest. I'm not going to go through and compute the exact number of interest here. I'm going to do that in Excel instead. I've gone ahead and made this into an Excel sheet. We started with $181,081 $1,000.24. Then we paid $1,500 a month, 8% interest. If we scroll down, note that I made one very large payment of $11,500 instead of $1,500, an extra $10,000. At the end of that month, the third year, 36th month, we owed $158,441.40. The next month, over in column A here, the lower payments, I lowered my payment to $1,410.95. Here, I left my payments the same. Notice that my balance is shrinking faster on this side. Let's zoom down all those months until the 218th month. That's about 18 years, where I make one smaller payment of $780. For the last one, I just added the interest to the balance owing, and that is $218. Going down over here, we pay for 2 more years, and this one is only about 70 cents less than the other ones. And in the end, we've paid $170,751 in interest over here with lower payments, but we've only paid $153,000 over here. So our difference is almost $20,000 worth of interest. In that case, it does make more sense to keep a higher payment.